Hello, welcome to the latest Math 10C video looking at greatest common factors. We're going to take a look at our outcome, review what common factors are, then we'll talk about greatest common factors, do some examples, exercises, and wrap it up with a summary. So, our curricular outcome. We're going to demonstrate an understanding of factors of whole numbers by determining the prime factors, greatest common factor, least common multiple, square root, and cube root. This time, we specifically focus on the greatest common factor. So, reviewing common factors in general. If one number, call it m, can be divided by another number n without remainder, then n is a factor of m. For example, 18 has factors of 1, 2, 3, 6, 9, and 18. 5 is not a factor because 18 divided by 5 gives 3 remainder. If two numbers n and m are both divisible by the same number g, then g is a common factor. For example, 92 and 96 are both divisible by 4, as well as 2 and 1. So 1 is a common factor of any pair of numbers. Now we'll take a look specifically at the greatest common factor. Should be familiar from working with fractions over the years, but we're starting a new course. We're doing the review because it will be used in a new way this year. So any pair of numbers is guaranteed to have a finite and non-zero number of common factors. So at least one could be many. All factors of a given number n must be less than or equal to n. So here we have an upper limit on the number of factors. The number of common factors between 15 and 20 has to be less than 15. It's a lot less than 15, but it has to be less than 15 because that's the smaller of our two numbers. All integers are divisible by 1. So there's our lower limit on the number of factors. 1 might be the only factor they have in common. You take two prime numbers, 1 will be their only common factor, but it'll be there. So if m is greater than n, you will have a greatest common factor for the two of them, call it g, and that greatest common factor is going to be between 1 and n. We just arbitrarily decided m is the bigger number, so our greatest common factor has to be between 1 and the smaller number. The greatest common factor is sometimes called the greatest common divisor. You'll see it marked both ways. So finding the greatest common factor, one way is factor lists. So one way to find the greatest common factor is to list all factors of both numbers and look for the greatest number on both lists. For example, the greatest common factor of 64 and 72. We look at the factors of 64. Well, it's 1 times 64, 2 times 32, 4 times 16, or 8 times 8. Factors of 72. Well, there's 1 in 72, 2 and times 36. It's divisible by 3, so we have 3 times 24. It's a multiple of 4. 4 times 18. Not a multiple of 5, it is a multiple of 6. That's 6 times 12. And not 7, but it is a multiple of 8. We actually get 8 times 9. 9 is the next number. It's already on the list, so these lists are complete. If I had a little more space, I would have them done vertically in tables, but I hope you get the idea here. So the common factors, there's 1, there's 2, there's 4, there's 8. Continuing checking the factors of 64, because that's the shorter list, are those on the list for 72. 72 is not a multiple of 16, or 32, or 64. So we've identified all 4 common factors. The greatest is 8. So there we go. Our greatest common factor of 64 and 72 is 8. So if you have the prime factorization of two numbers, you can also build the greatest common factor by assembling a number with the lowest exponent of each factor that appears on both factorizations. Note that factor has to be on both lists. So if we're looking at 72 and 108, prime factorization of 72 is 2 cubed, 3 squared. 108 is 2 squared, 3 cubed. So the greatest common factor will have some number of 2's and some number of 3's, because 2 and 3 appear on both lists. Let's take a look at our 2's. The lowest exponent is 2. When we compare that 2 and 3, 2 is the lowest, so 2 is the exponent we use in our greatest common factor. We look at our 3's. Exponents again are 2 and 3, 2 is the lowest, so 2 is what we use to build our greatest common factor. So 2 squared times 3 squared gives us 36. That is our greatest common factor. 36 times 2 is 72, 36 times 3 is 108. Now, we haven't officially introduced the least common multiple yet. That'll be our next video. But once you have it, you can also find the greatest common factor by a relationship. For any two numbers, the product of the numbers is the same as the product of the greatest common factor and their least common multiple. So if you already know the least common multiple, you can get the greatest common factor by multiplying the two numbers together and dividing by the least common multiple. If you have the greatest common factor, you can get the least common multiple by taking the two numbers, multiplying them together, dividing by the greatest common factor. So if you have, say, 36 and 42, and you somehow already know that their least common multiple is 252, then you could say 36 times 24 divided by 252. You work that out, and 6 is the greatest common factor of 36 and 42. You can also find greatest common factors with the Euclidean algorithm. I know this is the third way to find them. Some people are a little overwhelmed by multiple techniques. Most teachers don't demand multiple techniques unless the program of studies does. Most teachers will say, here's your options, pick one that works with you and stick with it. I personally like the Euclidean algorithm because you don't need to recognize any of the factors at all. So it was developed by Euclid about 2,000 years ago, a little over actually. So we take our two numbers. We divide the larger number by the smaller number. In this case, 221 divided by 143 gives us one remainder 78. We're going to take that remainder and divide it into our previous divisor. So in this case, we're going to take 143 divided by 78. That's one remainder 65. We take our two lowest numbers there, 78 and 65. We keep repeating this process until the remainder is 0. So in this case, 78 divided by 65 gives us one remainder 13. 65 divided by 13 is 5 remainder 0. Remainder 0 is what we're looking for. 13 is the greatest common factor. In fact, 221 is 13 times 17, and 143 is 13 times 11. So the Euclidean algorithm is useful when you have very large numbers or when you just don't recognize the factors. This method will extract them no matter what. You can use technology in Math 10C. So if you have a Texas Instruments calculator, you hit your math button, you go to the number submenu, pick option 9 for the greatest common divisor. You enter two numbers separated by commas. Yes, there is a comma button there. If you have 3 or more numbers, you got to start with 2 of them, find the greatest common divisor, and then take that answer, combine it with the third, and then that answer, combine it with the fourth, and so on. If you have a Casio calculator, you go option, number, F6, and then pick GCD. With the Casio, you don't need to do it 2 at a time. You could do 5, you could do 6. I don't know what the upper limit is. It's more than I've ever needed. But you enter the number separated by commas, and it finds the greatest common divisor of all of them. So let's take a look at some examples. Greatest common factor of 36 and 78. So here we do a prime factorization method. 36 is 2 squared times 3 squared. 78 is 2 times 3 times 13. So looking at our exponents, the lowest exponent of 2 is 1, the lowest exponent of 3 is 1. That gives us a greatest common factor of 2 times 3, which is 6. I omitted the 13 because it is not a factor of 36. We only use numbers that are on both lists. Right. The greatest common factor of these three, 144, 240, and 360. So we'll start by finding the greatest common factor of 144 and 240. That's actually 48. Now, the greatest common factor of 48 and 360 is 24. This will be the greatest common factor of all of them. So again, when you have more than two, you could find the greatest common factor of two of them, and then take that answer, find the greatest common factor with the third number. A third example. Timmy wants to organize his toys. He has 48 blocks and 36 toy cars. If he wants identical numbers of blocks and cars in each bag, how many bags does he need? All right, so the greatest common factor of 36 and 48 is 12. So we can put identical numbers of cars in all the bags and identical numbers of blocks in all the bags if he has 12 bags. Each bag will have 4 blocks and 3 cars. Not sure why Timmy chooses to organize his toys this way, but there we have it. All right, exercises give you a chance to practice some on your own. So, find the greatest common factor of 34 and 51. Pause now and take the time you need. The greatest common factor of these two is 17. 34 is 2 times 17, 51 is 3 times 17. Exercise 2. Find the greatest common factor of these three numbers, 54, 126, and 189. Pause now and take the time you need. All right, looking at the greatest common factor of these three. It is 9. We could do that with technology. We could break it down 2 at a time. This is what we eventually get to. They are all multiples of 9. All right, now we're back to Timmy organizing his toys. We've just changed the numbers. So the greatest common factor of 28 and 42. Pause now and take the time you need. All right, the greatest common factor is 14. So he'll need 14 bags with 2 blocks and 3 cars each. In summary, the greatest common factor, or greatest common divisor, is the greatest number which can be divided into a set of numbers with 0 remainder. It can be found most easily with factor lists, prime factorizations, the ratio of the product of the numbers with their least common multiple, which we'll cover more in the next lesson, and or the Euclidean algorithm. So, if you have any questions or feedback, leave them in the comments. I will try to get back to you in a timely fashion.